Your brain's reward system, the nucleus accumbens, responds to likes and comments within milliseconds. Contrary to popular belief, this instant feedback loop doesn't boost long-term happiness. Instead, it modifies dopamine pathways, recalibrating what brings pleasure. In 2017, Stanford University found that frequent social media use decreased dopamine receptor availability by 8% over just 2 months. This rewiring makes non-digital rewards seem less satisfying. Your brain is unknowingly trained to crave digital interaction, altering your perception of social fulfillment. The immediate, frequent dopamine hits from social media reinforce this loop. Every time you scroll through your feed, your prefrontal cortex, responsible for attention, experiences reduced activation. A 2018 University of Sussex study showed that multitasking on social media shrinks gray matter in this region by up to 15%. This structural change impairs your executive functions, making it harder to focus and plan. Contrary to the myth that multitasking improves efficiency, your brain is actually less equipped to manage tasks. The constant switching trains your brain to expect brief bursts of information, hindering deep cognitive processes. This rewiring emphasizes short-term gains over long-term goals. When you feel anxious about missing out, your amygdala, the brain's emotional center, hyperactivates. A 2019 study by UCLA found that social media-induced anxiety increased amygdala activity by 25% in teenagers. This hyperactivation links digital presence to emotional stress. Unlike the myth that social media connects us, it can amplify feelings of isolation. Your brain responds to notifications as urgent threats, triggering stress responses. This rewiring creates a feedback loop, where anxiety pushes you back to your devices for reassurance. The amygdala becomes conditioned to expect digital affirmation. Social media alters your memory by engaging the hippocampus, the brain's memory center, differently. A 2020 study from the University of Pennsylvania showed that curated online experiences disrupt memory consolidation. The sheer volume of information processed leads to fragmented memories. Contrary to the belief that sharing memories online enhances recall, it actually impairs the hippocampus's ability to form coherent narratives. Your brain prioritizes the act of sharing over the memory itself. This rewiring complicates your ability to retain meaningful events, altering how you perceive personal history. Habit loops form when digital cues trigger habitual responses in the basal ganglia. A 2016 MIT study documented how social media habits rely on this brain region for automatic behavior. The myth of willpower overlooks how these ingrained loops develop. Dopamine spikes occur with notifications, reinforcing the habit. Your brain learns to expect these digital rewards, even in the absence of conscious decision-making. This rewiring ensures your device becomes a habitual comfort. The basal ganglia solidifies these loops, making them resistant to change without intentional intervention. Cortisol, the stress hormone, impacts your hippocampal dendrite density. Under chronic stress from constant social media use, dendrites shrink. A 2018 study by Yale University revealed that sustained cortisol release reduced dendritic length by 10% within 6 weeks. This structural change weakens your memory and learning ability. Contrary to the myth of stress being solely emotional, cortisol physically alters your brain's architecture. The hippocampus, sensitive to stress, loses its capacity to form new memories. This rewiring diminishes cognitive flexibility, making it difficult to adapt to new information or situations. Amygdala prefrontal connectivity shifts as social media stimulates constant emotional engagement. A 2021 neuroscience study found that frequent notifications weaken this critical connection. Your prefrontal cortex, responsible for regulation, struggles to control the amygdala. This disconnection leads to impulsivity and emotional reactivity. The belief that digital interactions are harmless overlooks how they affect brain circuitry. Reduced connectivity means your emotional responses become exaggerated, with less rational oversight. The rewiring promotes emotional volatility, making it challenging to detach from social media emotionally. Dopamine receptor downregulation occurs as your brain adapts to constant social validation. A 2017 study from McGill University highlighted a 19% decrease in dopamine receptor availability in frequent social media users. This receptor downregulation means that your brain requires more stimulation to achieve the same level of satisfaction. The misconception that social media boosts happiness ignores these biochemical changes. Your brain becomes desensitized to natural rewards, needing increasingly intense digital interactions for equivalent pleasure. This rewiring alters how you experience joy and seek reward. The basal ganglia encodes habit loops when social media usage becomes routine. A 2019 Harvard study showed that digital habits form neural pathways solidified by repeated behavior. Dopamine signals reinforce these loops, enhancing compulsivity. Misunderstanding habits as merely psychological neglects their neural basis. The basal ganglia automates actions, making them less conscious. This rewiring locks you into habitual scrolling patterns, even when aware of its futility. The neural ingraining resists change, requiring significant effort to disrupt these loops. Default mode network activity increases with frequent social media browsing, altering self-referential thought. A 2020 MIT investigation found heightened activity in this network correlates with introspection and mind wandering. The common thought that social media simply passes time dismisses its impact on mental states. Your brain becomes more focused on internal narratives, often driven by social comparison. This rewiring enhances self-focused attention, potentially exacerbating feelings of inadequacy or low mood. The network's altered activity ingrains a pattern of introspective rumination. Chronic stress from digital engagement contrasts sharply with acute stress responses. While brief stress can enhance focus, chronic exposure, like constant notifications, floods your brain with cortisol. A 2016 study from the University of Michigan noted this flooding leads to structural changes in the brain. The myth that digital stressors are benign ignores their long-term effects. Prolonged cortisol exposure shrinks the hippocampus and enlarges the amygdala. This rewiring impairs memory and heightens emotional responses. Chronic digital stress leaves your brain primed for anxiety and overreaction. The self-help industry often claims that simply limiting screen time can resolve digital stress. However, peer-reviewed neuroscience reveals more persistent brain changes. The National Institute of Mental Health in 2021 demonstrated how social media affects BDNF expression. Brain-derived neurotrophic factor is crucial for neuroplasticity and resilience. Frequent usage reduced BDNF levels by 12%, hindering brain adaptability. This rewiring lessens your ability to recover from digital stress. Unlike the quick fixes suggested, these cellular changes require sustained interventions for reversal. The brain's resilience is chemically altered. Brain imaging studies reveal truths that contradict popular psychology. Functional MRI data from a 2022 study at Stanford University showed decreased activity in reward pathways among heavy social media users. Unlike the belief that digital engagement always provides pleasure, the nucleus accumbens shows diminished activation. This rewiring results in a blunted response to rewards, both digital and real. The brain's altered response makes it harder to derive satisfaction from offline activities. The imaging data paints a picture of a desensitized reward system. Synaptic pruning in adolescence plays a crucial role in brain development. However, excessive social media use can alter this pruning process. A 2020 Johns Hopkins study found that adolescents exposed to high digital engagement experienced accelerated synaptic pruning. This means the brain may eliminate connections prematurely. Unlike the assumption that teens adapt easily, these changes impact learning and behavior. The rewiring reduces cognitive flexibility, leading to potential social and academic challenges. The pruning process, crucial for efficiency, is disrupted by digital habits. A 2021 study from the University of California reframes social media's long-term effects. Researchers found that 34% of users reported altered sleep patterns. This is not merely a habit, it's a physiological shift. The study showed increased blue light exposure reduced melatonin production by 20%. This biochemical change affects sleep quality and brain restoration. Contrary to claims that screen time adjustments can resolve these issues, the brain's natural cycles are fundamentally disrupted. The rewiring affects not just behavior but fundamental biological rhythms.